Hi, thank you for joining me for this virtual presentation titled Planting Date Effect upon Leaf Spot Disease and Pod Yield Across Years in Peanut Genotypes. I'll be presenting this talk for Bill Branch. My name is Nino Brown, and we collaborated with Albert Colbreth on this project. The structure of my talk will follow that of the paper. I'll give a brief introduction to leaf spot diseases in Georgia and their impact on production, followed by the methods we use to conduct the experiment, and then we'll get into the results and a brief summary will follow. The impact of late leaf spot and early leaf spot is significant. In 2017, the peanut crop in Georgia was valued at $825 million, and almost 16% of that was lost to damages from these diseases or spent on control measures targeting them. That's 12.4 million and 40.3 million respectively, a significant amount of money. The image at the top left, labeled A, shows an early leaf spot lesion. It's brown with a chlorotic halo around it. And then the image at the top right, labeled B, shows a late leaf spot lesion. It's more of a blackish color, doesn't have the characteristic yellow halo that an early leaf spot lesion does, and it sporulates on the bottom part of the leaf. And the image of the leaf at the bottom right is a really good example of both diseases being present on the same leaf, which is a pretty common sight, especially late in the season or where disease pressure is really high. So these graphs are from Fulmer et al. In 2019. They show risk points or risk factors on the x-axis and the timing of disease progression through the growing season. Early leaf spot is on the left, and it shows outbreaks can start as early as 30 to 40 days after planting, depending on your risk factors, all the way through crop maturity, whereas late leaf spot comes in as early as 70 days after planting on through to maturity, again depending on your risk factors. Current leaf spot control strategies include chemical controls, of which there are some really good fungicides available. They're very effective, but they're an extra cost and are expensive. Planting date has been shown to have an effect on severity. Good rotation can also have a very positive impact, as well as cultivar selection, and there are some with fair resistance available. So the objective of this experiment was to evaluate a range of genotypes for leaf spot resistance at 3 planting dates, each for 3 years with no fungicides. The trials were planted in Tifton, Georgia at the Gibbs Research Farm in the same field every 3 years. April plantings were usually around the 2nd or 3rd week of April, whereas for all 3 years, whereas May plantings were always on May 11th, and June plantings always on June 1st for all 3 years. Entries were replicated 5 times in a randomized complete block design. These are 2-row plots that were 6.1 meters long. We practiced conventional tillage and fertility, and the fields were in a good 3-year rotation with corn and cotton. They were irrigated, and no fungicides were used. So we used a visual canopy rating to evaluate early and late leaf spot together rather than trying to separate the two. The scale used was from a 0 to 9, with a 0 having no leaf spot, that is highly resistant, and a 9 being totally defoliated and a dead plot. In the image here, we have a 9 indicated. You can see there are no green leaves left. The vines are totally defoliated and dead. And then 2 plots to its right is a genotype we would rate as a 6. There is significant defoliation, but the plot's still green, and a few leaves are still present. 2 ranges back from it is a genotype that we would give a 4. It still has a great deal of leaves, it's fairly healthy, but leaf spots are present, and some limited defoliation has occurred. So to determine harvest or timing of harvest, we use the whole scrape method on adjacent plots to gauge maturity, with more resistant lines usually harvested at optimum maturity. However, highly susceptible lines sometimes had to be harvested due to high levels of defoliation and vine degradation. The 9 I showed in the previous slide is a good example of that. Significant differences were seen within planting dates and between planting dates, and then years were analyzed separately here. So that brings us to the results. The results will be presented in a similar manner for the remaining slides. On the x-axis, genotypes are sorted in ascending order for their average leaf spot rating for the given year. Thus, Georganic had the lowest leaf spot rating in 2012, and Flowrun 107 had the highest average leaf spot rating for 2012. So the leaf spot rating is indicated on the y-axis. Subsequent pod yield slides that I'll show in a moment will remain in the same order for each of the given years. So we'll have lowest leaf spot rating on the left and highest leaf spot rating on the right. Highlighting in blue indicates the highest or best significance group, and red highlighting indicates the lowest or worst significance group for the remaining slides. This particular slide represents leaf spot ratings for the April planted trial in 2012. Georgia 13M and Flowrun 107 had the highest leaf spot ratings, and the lowest ratings were seen for Georganic and some of the Georgia breeding lines. For the May planted trial, lowest leaf spot ratings were again seen in Georganic and a couple of the breeding lines. Lines with the highest ratings included Georgia 10T, Florida 07, Georgia 6G, Georgia Greener, Florida EP 113, Georgia 13M, and Flowrun 107. Several genotypes were in the highest significance group for the June planted trial, but Georganic stood out with the lowest leaf spot rating. Averaged across the three planting dates in 2012, the highest leaf spot ratings were seen in Florida EP 113, Georgia 13M, and Flowrun 107, with the lowest leaf spot rating seen in Georganic and Georgia breeding line 07, 25, 23. Here we have pod yields, which didn't always follow the leaf spot ratings, but average yield for the April planted trial was a little over 6,000 kilograms per hectare. Lowest yielding genotypes were some of the more resistant genotypes to leaf spot, except for Georgia 10T here. But the highest yielding genotype was Georgia 12Y. Pod yields for the May planted trial were significantly lower on average than the April planted trial. Lowest yielding genotypes were Florida EP 113, Flowrun 107, and a breeding line 082546. The highest yielding genotypes included Georgia 12Y, Tough Runner 727, Georgia 10T, and some of the Georgia breeding lines. The June planted pod yields were quite low, averaging around 2,900 kilograms per hectare, and the highest yielding genotype was Georgia 12Y in this trial. Averaged across 2012, the highest pod yields were seen in cultivars Georgia 12Y, Tough Runner 727, and a couple of the Georgia breeding lines. The April planted trial in 2015 saw Georgia 18RU and Tough Runner 511 with the highest leaf spot ratings, and Georganic again with the lowest leaf spot rating, along with several of the Georgia breeding lines. Average leaf spot rating increased significantly from 3.7 in the previous slide to 6.4 in the May planted trial. Again, Georgia 18RU, Tough Runner 511 had the highest level of leaf spot, along with Georgia 122544. Georganic and some of the breeding lines had the lowest leaf spot ratings. Average leaf spot rating climbed to 7.3 in the June planting, with essentially the same lines in the highest and lowest significant groups. The mean leaf spot ratings for 2015 were highest for Georgia 18RU and Tough Runner 511, with Georganic and a few Georgia breeding lines having the lowest. In the April planted trial, interestingly, several lines with high levels of leaf spot were in the highest yield group, including Georgia 18RU, Georgia 06G, Tifton, and Georgia 12Y. The highest yielding group was quite large for the May 2015 trial. However, the lowest yielding group included a line with the highest leaf spot rating, a middle of the pack rating, and one of the lowest leaf spot ratings. So those were Tough Runner 511, Breeding Line Georgia 13 2707, and Georganic. The highest yielding group for the June planted trial included those genotypes with lower leaf spot ratings. The lowest yielding genotype also had the highest levels of leaf spot in this trial. 2015 did not see a great deal of significant difference for yield. But the genotype with the highest average leaf spot rating also saw the lowest yield. That's Tough Runner 511. In 2018, the April planted trial saw average leaf spot ratings of only 2.8, so pretty low. Genotypes in the lowest significance group included Georgia Breeding Line 13 2705, Georgia 14N, Georgia 19HP, Tifton V HIOL, and Georgia 13 2712. Genotypes with the highest leaf spot rating were Tough Runner 297 and Georgia 1525-37. Georgia 1525-37 again had the highest leaf spot rating in the May planted trial, with the lowest ratings given to cultivars Georgia 14N, Georgia 19HP, Auburn MPL 17, Tifton V HIOL, Tifton, and Georgia Breeding Lines 13 2705 and 1525-45. The June planted trial saw the highest leaf spot ratings in Georgia 14 27 28 and Georgia 15 25 37 and Tough Runner 297. The lowest leaf spot rating was seen for Georgia 13 27 05. Averaged across 2018, cultivars with the lowest leaf spot rating were Georgia 14N, Georgia 19HP, Auburn MPL 17, Tifton V HIOL, Tifton, and Georgia 12Y. Highest pod yields were seen in the lines with high leaf spot rating, and the lowest yields for Georgia 13 2705 and Georgia 14N, which had the lowest leaf spot ratings in 2018. The May planted trial saw Georgia 14N and Georgia 1525-37 with the lowest pod yield. The June planted trial saw the lowest yields in the most susceptible lines, Tough Runner 297 and Georgia 1525-37. Highest yields were seen in genotypes with lower leaf spot ratings here. Averaged across 2018, the highest yielding cultivars were Georgia 12Y, Georgia 19HP, Auburn MPL 17, Flow Run 331, Georgia Greener, and Georgia 6G. And that brings me to the summary. So the effective planting date was significant. Pod yields decreased from April to June. Leaf spot ratings increased from April to June. And the highest yield and lowest leaf spot ratings were achieved with April planting dates. As far as genotypic performance, significant differences were evident among genotypes for both yield and leaf spot rating. Georgia 12Y didn't have the lowest leaf spot rating always, but did have some of the highest pod yields across these 3 years. Leaf spot resistance alone did not equal high yield performance, as indicated by some genotypes with higher leaf spot resistance than Georgia 12Y. So with that, I thank you for your time and attention, and I would be happy to answer any questions you might have through email. Thank you.